And yeah, who really I admired, and he was my Google Summer of Code 2019, the mentor, amazing guy, and where the Go community building experience is mostly coming from. You can see from meeting minutes, everything is coming from Meshery community. And regarding one example I can tell regarding the Meshery, that intern, regarding the intern, that was internally asked me to talk Adnan a year ago, and I talked. He basically had no background, like so much foundation knowledge missing. I was thinking, man, to bringing up this guy to speed gonna be too much effort. But Lee didn't give up. He really believed, and this guy, in 2 months ago, he got to internship in the Red Hat. Red Hat, you know, just they don't hire random interns. I mean, when I was amazed at how Lee, in that short amount of time, bring these guys. He was based in India, and he and 2 more friends. So bring these guys without zero kind of commitment. It was amazingly. Floor is yours. Thank you so much again.
Oh yeah, no, well, see, the part that Sako is leaving out in that story is his role in up-leveling Anand, well, and not just Anand, but Nikhil and Shubham. They're all students, all seniors at a university in India. The UEM Jaipur is the name of the university. Yeah, I guess I get a chuckle because there's a couple of all three of those students actually landed internships at Red Hat in various groups. And it was, yeah, in large part due to folks like Sako engaging with them, exercising some patience, showing them what he knows. Hopefully, as part of that, he too was learning how to be improving his mentorship skills. You know, it's half of why it is that I enjoy sharing with others, is because I'm pretty sure it's every time, and I suspect it will happen again today, that I end up learning something. So it's not, for as much as I might like to present it as an altruistic thing, there's some selfish components. I get fed. It's fantastic to see others grow. As part of their growth, I really do consider that that's my growth as well. And that's a core component of this particular community, the Layer 5 community. It's a community that, from a technology perspective, is focused on service meshes. Service meshes as a sort of a, well, we'll talk about service meshes, but so while it's focused on that particular technology, it does envelope many other cloud native technologies. And yeah, core to the culture is, well, it really resonates, I think, with the mission statement of Goop. I liked how kind of the first part of that statement was to build an egoless environment. I think there's more to what that statement is, but I sort of stopped there at the second word, which I really haven't seen described in many other open source communities. I think they describe it as being inclusive, or supporting diversity, or not being prejudiced against age, sex, or sort of, you know, all of these other things. But actually, I don't know how often they speak to something like Goop has around ego, which is actually, I think, how we sort of started the intro to this talk, which is me saying, I might learn something today. I've been doing nerd stuff for 20-something years. I've been letting my little inner geek just sort of lead the way, stuffing tech into his mouth as fast as I can. And it turns out that's a nice little cycle. It's sort of, the more that you let those passions go, and the more that you feed them, or this is a generality, and this is generally proven true for me. I've occasionally gotten in trouble for being, maybe allowing my ADD, if you will, to sort of lead the way as I kind of sort of stay afloat on emerging tech. But to me, that nice cycle and kind of chasing your passions, I think, is probably a fairly cliched statement, because I think you hear that from a lot of people, and that's true. I recall one of the first times that I got that I was receiving a paycheck for doing something that I would have otherwise done anyway. And I just thought, what a silly thing this is, or what a beautiful thing this is, that these fools are paying me to do this stuff. So I've been chasing that ever since. And really any amount of accolades that I've had in my past are due to mentors that I've had, are due to some of my own grit, sure, but are also some of it's been luck, and some of it's just been, you know, getting back up after you fall off the horse, or, you know, not. Some of it's been having humility. I think Garib, who was speaking, clearly he's been leading people for quite some time. There's a lot of truths in the things that he was saying about. I don't know that he said this as directly, so I'll go ahead and be on record and say this, but I'd much rather have someone on the team who is less capable, but has a better attitude, uplifts others, it helps, believes in the vision, or if they don't, helps, you know, influence that vision, than I would necessarily have a super bright asshole of an engineer on the team, you know, spoiling it for the rest of us. And so yeah, so all right, so anyway, about layer 5 and service meshes is, I was going to say that, you know, service meshes, for those that are familiar and those that aren't, we'll talk about the tech a little bit, and then talk about kind of a project that the community has got going on. I've got about 3 projects. So we're all familiar with Docker, that lit on fire, you know, about 6-7 years ago now. I think it was announced 7 years ago at PyCon. And then about 5.5 years ago went GA, or went 1.0. And in some respects, I think if you look at that, I don't know if you either interpret it as being, wow, that was a long time ago, or wow, hey, that was a short time ago, considering how pervasive the technology is now. And then, you know, we entered in, you know, people started using containers and using lots of them. So we entered into the age of container orchestration, and we had that war and those battles. The leading container orchestrator was announced 5.5 years ago, and about 4.5 years ago it 1.0. You know, it GA'd. As we enter into this next phase of expecting more from your cloud native infrastructure, this next phase of not just orchestrating clusters and nodes, containers and their scheduling, but beginning to up-level the smarts of the infrastructure toward, well, maybe that's the wrong way of phrasing it, but up-leveling the focus of the infrastructure more toward layer 7, or more toward that application, which I would consider to be sort of the king, if you will. It's kind of why we run this infrastructure for those apps. And so service meshes as a technology, it's a little bit tongue-in-cheek, but they more or less reside at kind of layer 5, sort of the session layer in the OSI model, if you will. The Linkerd v1 was announced 4 years ago. It GA'd, I guess that's confusing when I say v1, being announced 4 years ago. The first architecture of Linkerd was announced that time ago. It 1.0 3 years ago. About 2 years ago, though, there was a Linkerd v2. It's a complete new architecture, new code base and all. But point is, the time frame is kind of intriguing and sort of interesting to watch the scale of adoption of these technologies. It's my belief, and I hope a shared belief amongst those in the layer 5 community, that you know, that service meshes, it's only a matter of time before they are ubiquitously adopted. That really anywhere you would see a Kubernetes, that you would just expect to see a service mesh. And it wouldn't be, you know, there are reasons not to have one. But, you know, just as you walk into an environment today, and if you take a look at software that's being sustained, or a new project's being created, you kind of expect that, you know, Docker is in there somewhere, containers in there. I think that that's the same, you would have that same expectation of the presence of a service mesh in the future. So as the community layer 5 goes to focus on service meshes, there are 3 sort of projects that are being stewarded, that are being created. One of those is, and so we'll talk about each of these 3. Meshery is the sort of largest of these 3. The first one is, well, it's a community curated landscape of service meshes. Turns out, even though I suspect most of us on this call could really only prattle off, you know, 3 or 4 at most service meshes, turns out there's more like 20 of them out there. There's a lot of reuse. Some of them look pretty similar. Some of them look completely different. And so there's a community curated landscape of a listing of those service meshes and also some related technology. Some of that related technology are proxies, so, and client-side libraries. Maybe we won't talk about those, but you can see them on the landscape. There's some reasons why it's a bit meshy out there. There's some reasons why there are multiple of these things. These are some of them. I have a tendency to be long-winded, and so I'm gonna let you guys read into that. But just suffice to say, at least for today, it is a multi-mesh world. It's possible that that might change in the future, and just speaking in generalities about products or projects and how they are adopted, in general, it's typically the case that there is one that enjoys the majority of adoption, whether it's technology or just products in general, and you know, kind of a second and third that enjoy a fair bit, and then sort of all the rest that kind of have a sliver of it. It's my hope that, for my part, it's my hope that we don't end up in a world where one mesh has one, and it's really only that mesh. I guess on that subject, I'll say that while Kubernetes is a great piece of technology, I think it's something of a shame that we collectively, and I'm at fault here as well, express some technology bigotry fairly frequently. If I was to say, hey, by show of hands, who's using or what, who's running containers, who's running an orchestrator, is anyone running Nomad, or is anyone running Docker Swarm? Some of us might be embarrassed to raise our hand on that, because they're following up on that might be some shame or people trying to shame. And I actually think it's a shame that that we don't say, hey, it's actually a really smart decision to run Nomad if you're running on a Windows environment and if you're doing batch jobs. Nomad's awesome for that. Or why would you try to fit something else just because it's very popular in there? So on the subject of the world being of multiple meshes today, because of that, there are some service mesh abstractions that have come to bear. It was about 4 weeks ago now that I had approved SMI, service mesh interface, as being allowed or donated to the CNCF. There's a number of hats that I wear in the community, and one of those is as a chair for the CNCF's SIG network. I also wear a maintainer hat on SMI, and SMI, if you're not familiar, just very briefly, is it's a specification. It's a specification and interface for describing the lowest common denominator functionality across many meshes. And as it does this, it's doing it only in context of Kubernetes. So there's another emerging specification. It's about a year old now, that focuses on federation of either homogeneous or heterogeneous service meshes and the exchange of the catalog of services between them. It's actually, in some respects, my opinion that this is a bit more of an interesting spec. And there's a third one emerging that I'm going to tell you more about today, but it's focused on service mesh performance and how to measure service mesh performance in context of the overhead that a mesh has. So I've been going around flapping my lips about meshy things for a while, and in doing that early on, I got kind of two questions consistently from people about, well, about which service mesh to run, how to get started with them, and then the other one about trying to understand the overhead that occurs as you're running one of these in your infrastructure. And so I guess, briefly, for those that aren't familiar with a service mesh, their general architecture is such that they generally are composed of a data plane and a control plane. Most of us or I think for a lot of you, these might make some sense. I think an analogy here that might resonate is that most of you are familiar with Kubernetes control plane, and some of it's the Kubernetes master, if you will. The data plane, kind of, to make this analogy, the data plane there is the nodes inside the cluster. For the service mesh, the data plane is comprised of a number of network proxies. And it's the management of those proxies that is the responsibility of the control plane. If you're familiar with or have a background in networking, I think these terms can resonate with you, that there's also the concept of a management plane. There's outside of a control plane, focusing on a specific set of proxies, and that control plane being opinionated about, basically being the brains behind console or Istio or Linkerd, or the brains behind a given specific mesh. You might want to integrate across meshes. You might want to integrate with your backend systems that you're already using for monitoring, or you might want to federate the service catalogs between them. You might want to perform chaos engineering, or there's all kinds of things to do on top of a mesh that a service mesh enables, but that the native control planes themselves don't necessarily provide. And so hence, we've gone out to create, and by we, I mean, just sort of, I'm looking around the room, Vergun and Sako and Nabi are all names that come to mind of folks that have been over just either been over helping with this initiative, whether just, and really, like, this is, to step as an aside for a second, I would say it's sort of another thing that I think communities sometimes get wrong is how much code contributions are valued. And don't get me wrong, like open source code contributions, those are awesome. But equally as awesome is the person using the thing and providing feedback, or the person documenting, or the person being willing to speak on it. And we're going to, forthcoming soon in the layer 5 community, we're going to be purposeful about expressing how it is that we weigh the value of those different types of contributions. So that was kind of an aside, but Meshery itself was started about a year ago. A couple of us got together and started, and anymore it's fairly shortly. First half of this year, it'll be inside the CNCF. It achieves the core infrastructure initiative best practices for how to run an open source project. It's, Sako had mentioned that it's participated in Google Summer of Code. It's second year going now. So Sako was the sort of the champion and the individual to prove that this was that this could work, and it did. And so now we've got two Google Summer of Code interns. Actually, we'll have a Community Bridge intern, and then hopefully a Google Season of Docs intern as well. Meshery and Layer 5 are SMI partners, Service Mesh Interface compatible partners. Meshery as a system, I'm going to try to move a bit more quickly because I think I'm probably about to, Sako will interrupt me when I start to eat into someone else's time. So
no, you're good, Lee. Perfect. No worries.
So Meshery itself, while I think up front, a lot of times we talked about it as a project, it as a tool, integrating with more service meshes than any other project available in the world, or product. But that's not, that's excellent. That's not its true value. Its true value is being able to manage the life cycle of a given mesh, or tell you that you've got your configuration, you don't have your service mesh configured in a best practices way. It will analyze the config of your mesh and tell you that. It'll analyze the config of your workload and tell you that. Maybe when you're trying to understand and weigh, understand what that performance overhead is, understand, and compare that in context of the value that you're getting out of the mesh. That's another piece of value that it provides. And so there's quite some long roadmap actually for Meshery. This is a screenshot of one of its interfaces today. It is a project that does provide, or that does have a user interface to it. It does have a CLI. It does have a web-based user interface. Not all open source projects do, but turns out, I think that sort of the longer that open source grows and grows and grows, kind of the harder in some respects it is to get a project off the ground, because there's just, the bar continues to get raised for people, for individuals like all of us that go out and choose a tool. There's many factors I think that we consider when we go to use a tool. It's like, who's behind it? How capable is it? Is it actively being supported, and et cetera? And so, to Sako's point earlier, it's no small thing to gather up all that energy and get other folks excited about the vision for a project. And there's a point in there too that, like, hey, if that vision isn't malleable, or if other people aren't allowed a space to express their opinions and to make their mark and to make their name, then I think that that's also been a failure of other communities. And so just random community kind of thoughts inserted in there, just as we reflect on Kiss.conf and what it's doing, which is great. So that we've been fortunate that we've got maintainers from VMware, Octarine, Citrix, HashiCorp, from a number of other communities or companies coming to bear on the project. This is a quick view of the architecture of the project, not very complex, in so much as Meshery itself deploys as a set of Docker containers. You can deploy Meshery on a host that only has Docker, so on your local machine, or you can deploy it in a Kubernetes environment, sort of. So in some respects, you can deploy it out of cluster or in cluster. Meshery has an API and some of these UIs. It has adapters for each of the service meshes that you see pictured. It'll interface with Prometheus and Grafana. It is initially created to help answer questions that people have while they're trying to adopt and learn and understand a service mesh and maybe choose which one they want to run. Immediately after that, when someone makes that choice, the next persona that it addresses is the operator. It helps you ongoing manage your service mesh and the workloads on top of it. Eventually, it's our hope that we'll be addressing developers a bit more squarely, as well as then product owners. And there are some really intriguing use cases that we're going to chase after for those last two personas that come see me another time if those interest. I'm gonna try to maybe give a demo of Meshery if we have time. So quickly I'll say that we're also just generally engaged with the CNCF, with a bunch of partners. We'll talk more about those, but we're recently creating a service mesh performance working group inside the CNCF. We're gonna do some distributed performance testing. So part of the impact that Sako had on the Meshery project was to bring forth support for multiple load generators. Part of how the value that Meshery provides is to assess the performance of your service mesh. And one of the ways that it does that is by generating a bunch of HTTP load against your endpoints. and then measuring the latency of their response, measuring the throughput by which it can shove a bunch of load against your service. And there's a bunch of, turns out like performance engineering is quite involved. And so we're going to go off and hopefully we'll be creating a service mesh performance specification. So a new spec that is vendor agnostic. And will hopefully be the canonical way in which people describe the performance of their mesh. I think quickly the analogy that I would draw here is that if you're at home and you're having bandwidth challenges and you go to test your bandwidth speed, your internet bandwidth speed, that you could think of the capability here as being kind of similar, that you might use this tool and this specification to just get an assessment of the performance of your mesh. So we'll show it. I figured we'd have a slide in here a little bit about the community and kind of its timeframes, some of the metrics around the community, young community. We've been fortunate to find other like-minded nerds that want to, that are willing to spend some time. So some of these, if for nothing else, just help those that are involved feel recognized and feel seen, if you will, about the contributions that they're making. One of them will be on stage one of the contributors will be on stage at DockerCon, the virtual conference coming up.
I think Lee Kush just joined from Meshery, so.
Oh, very good. And so, so nice, good. So, and Kush, good. One of them will be on stage at DockerCon. Another one will be on stage at KubeCon EU. Both of these are now virtual conferences. So my point of highlighting that was to say that, kind of in context of community building, and is that recognition is important, or the ability to share with others and get feedback is important. And it's, I'm tickled that those that are giving as much of their time, like Kush is, are afforded opportunity to have their name highlighted. Like it's, what a beautiful, again, kind of virtuous cycle that occurs here. We've also been fortunate to go off and establish formal partnerships with the logos that you see here. So I, for one, am really stretched thin in trying to maintain these partnerships and do these things. And it's like, if I haven't made it extraordinarily evident, there's no way that much of this could have been accomplished without folks like Sako and Burgan and Nabi and Kush joining and doing things. I'll ask.
Keeping coming.
Yeah. And so I guess that's an implicit open invite to anyone who's interested in joining to learn, to take a look at how the community is being run, or to dig into any of the tech that goes on. All of the above are welcome. Sako, I lost track of time. We don't need to.
You have 20 more minutes, no worries. You're good, Lee.
Okay, say it again, yeah. The number of minutes?
20 more minutes. 20 more minutes.
Oh, okay. Wait, 20 or?
20.
Okay. Oh, geez.
You're good. No.
Very good. No, it's, I just saying, oh, geez, I can't believe
You're doing good.
I usually can't get myself to shut up and so. Well, this is great. So, by the way, I didn't really pause for questions in between the slides and things. There might have been some chat going on, and so it may be a good time to go back. Do we have?
Meshery community is spamming they keep coming, Lee. So it's becoming more Meshery fireside community call. Nice. Thank you, everybody.
Yeah, it's good. Yeah. So there were, so one of the questions was, does Meshery assume multi-mesh deployments in infrastructures and provide its value in bridging them? Yeah, this is a great question. Because if I only have a single service mesh, like just a Linkerd deployment, what value would Meshery bring? performance testing is one-off value. What are the ongoing values that it might bring, if any? That's a great question. I'll submit to you this, that, well, let's demo it and show you. That was actually kind of one of the things I was trying to speak to before, is that it's great that it connects to so many service meshes, and that's kind of this aha moment after it's provided its true value. Some of that immediate value that we worked on initially is about adoption, and facilitate as one of like the first questions that people have, which is why we do life cycle management of those meshes. And we focus on some of those adoption questions. As the project evolves, it will provide more ongoing kind of day two value, if you will. The performance testing is an interesting thing, as I think it strikes a lot of folks that it might be a sort of a one-time question, like, hey, once I've adopted, great, then I don't need this tool anymore. And part of my adoption consideration was performance. As it turns out, performance is an ongoing concern. Once you've chosen to deploy a mesh, you've deployed your workloads, turns out like your environments change. Sometimes you add a node or take away a node. Sometimes you roll out a new release of your workload. Sometimes you upgrade the service mesh itself. Sometimes you change the service mesh config and have it do more things or less things. Any of those changes affect how your mesh is performing and the value it's providing. Also ultimately affects the performance of your workload, of your application. So for my part, I consider that that tracking that performance is certainly is a day 0, 1, and 2 concern, meaning an adoption and ongoing concern. And I guess so we originally talked about the project as being something of a tool to provide a benchmark around performance, and it does. That's in part what the spec is to do, is to benchmark these service meshes and hold the vendors of them or the maintainers of them to the same measurement. But it's also meant to baseline your environment. So kind of like I was just describing, that you would get your environment up, baseline it, benchmark your environment, and then ongoing as changes are made, come back to continue to measure changes and to facilitate that. I'm just looking back in a history of having run some performance tests, and maybe we can run some here. But that you're able to run one and compare one to another, or to 3, or to 4, or to 5. And so this maybe speaks a bit more to the ongoing value that that performance management would have, is to understand over time how maybe there's nothing that's changed in your environment, and yet you're either seeing consistency with the performance of your mesh and the performance of your apps, or not. And so actually the KubeCon talk that was well, it's coming up, but it was to be delivered, was to help people understand the cost of a given network function. So if you told the mesh to introspect a packet, take a look at a JWT token, maybe who's signed in, and do something based on that, like how much does that thing, that one little service mesh function cost you? And is it a higher cost if you're using JWT versus cookies, or versus this, or versus? And so, yeah, the more that the project unfolds, and the more rock stars like Kush show up, the deeper the deeper of an answer we'll have there. So, Elvin, that was a fantastic question. I think another one that had come out was that, you have experience with many service mesh solutions. So yeah, which one do you think is a better solution for multi-cluster Kubernetes infrastructure where the network is not flat? And so Elvin, that's another fantastic question, and both of yours feed right into part of what Meshery is attempting to accomplish, which is that exact question about like, hey, which one should you use? And then, you know, considering that the environment looks like this, this, or this. Well, I've got some opinions. And you're right, I've been focused in the space for a while. I've published a few books through O'Reilly on service meshes, and we'll be doing a third one here. Well, we'll see how long it takes, but I'm gonna withhold those opinions. Not because we're recording, or not because I'm afraid that people might flame me on Twitter or what have you, actually because that's in part why we built Meshery. And that's in part why it connects to so many. I would love it if you went and grabbed the tool and answered that question, came back and told me or told the community, here's what you consider that is the best mesh based on the fact that you're able to take Meshery, deploy a few different meshes in the environment that you're talking about, a multi-cluster Kubernetes environment with hierarchical or multiple, with routed networks. That's an awesome, yeah. I hope that is a good teaser for you and doesn't piss you off that I didn't answer the question directly. That's not my intention. My intention is just like, that's perfect. We would love to have a user tell us, Meshery doesn't really answer that question, I think, but because that's why we built it, is like to be able to help you answer that question. Because part of it is, how many networks are there? And like how many clusters? And so what is that workload that you're running? Like I can tell you based off of certain types of workloads or categories of those, but they may not be what your environment is. And so that's in part why we built the tool, because for those that have gone off before us and produced benchmarks or have done analyses, performance analyses around service meshes in various environments, it's inevitable that, well, it was a point in time, like, yeah, they did some great ones back on Istio 1.0 and Linkerd such and such, but they didn't do it across more than 2 at a time, which means that when you do another comparison, you read about console versus Linkerd, it's like, well, that was a totally different environment, totally different setup. It was also back at that point in time. It wasn't my environment, it wasn't my setup. I'm also not running that version. Hence, hopefully, Elvin, part of the value of the tool is take it, do it in your environment specific to you. Those are fantastic questions. And
by the way, Lee, just briefly, Elvin is one of the maintainers for the Nginx ingress controller. He's gonna post today the last session 5. You can give him some hard time during that session. So.
Oh yeah, no, no, Elvin. I mean, like, yeah, no, that's perfect. That's perfect. Please.
Amazing
please.
question. Thank you. Yeah. Elvin.
So if there's any time left, I think that the thing I kind of sort of implicitly kind of gave a little bit of a demo of the project. As a matter of fact, we're looking at some things right here. This button, Kush brought forward here, I think last week. So we're already seeing his works up on stage. The project itself, kind of like the community, well, it's hopeful that of the functionality that it provides today, and as additional functionality is added, is that it's done in a way in which delights people, and so that people love the tool and tell others about it, and then others come to bear and make their mark, like Kush has, like Sako has. An example of what I mean by the project being delightful is something like, well, and actually I would love for any or all of you to try this and see if this proved me wrong, and that's that, or prove me right. That's that this project, if you go to install it, there's actually a bunch of ways to install it. It supports a bunch of different package systems like Brew and Scoop, and deploying on various environments. But depending upon what command you end up using or how it is that you deploy, it's the case that you can use this command to deploy or execute one command. And with only one command, it'll download Meshery, run Meshery, and bring up your web-based interface and drop you at the login prompt. And to me, well, that's kind of nice, because normally when you're installing a piece of software, there's a couple of steps that you need to do. And it's not like those steps are usually a big hassle, but hopefully that delights people a little bit. And there's a few Easter eggs in there, if you will, or things that maybe give people a chuckle. So I figured if and again, just cut me off when we're out of time, but I figured we do this brief demo of Meshery itself. So this is the UI. It does connect to, you know, it is, how should I say this? Meshery will provide some of that performance, will provide some of its value, whether you're running in a Kubernetes environment or not. So if we wanted to run a test if we wanted to run a test of a workload that's not on a mesh, and maybe that workload isn't even local to me, that hey, this load generator can go out and perform that test. And I shouldn't have set it to 30 seconds because that means that I've got to make a funny joke or something like that as we look at this. But part of what Meshery will do is it operates, it wants to operate, it'll operate in a Kubernetes environment or out of it. That was kind of the point of what I was trying to demo here. It'll connect to Prometheus, it'll connect to Grafana if you have those in your environment. Most of the service meshes in their control planes, they'll come with a small instance of Grafana and Prometheus. And so it'll pull in any Grafana boards that you have predefined so that you can, well, analyze the latency and throughput of all of those requests and how your service responds back to you, and the consistency by which it responds back to you. You can do that in context of the effect that it has on your environment. And right now we're really not seeing an effect on the environment because I was hammering google.com with a bunch of GET requests, not our local deployment. So, and so, yeah, I guess that's a couple of things. That's an example of Meshery connecting to other pieces of infrastructure, including Kubernetes, as well as testing things off the mesh and on the mesh. We looked at the results and how you can compare those over time. Meshery, of the adapters that are there, so right now in the environment that I'm in, I'm just running Meshery on my local iMac, and I'm actually running Meshery in Docker desktop. I'm running Meshery in Docker. Docker desktop is also running Kubernetes for me. So the Meshery deployment is outside of Kubernetes. And we can go ahead and, because these adapters are present, we can go ahead and deploy these different service meshes. If we go over and take a look at the Istio adapter, the adapters are not made equal, meaning if we look at the network service mesh adapter, this service mesh here is called network service mesh, the group of maintainers there gave it a very generic name. And anyway, it doesn't have as many capabilities. So unlike service mesh interface, SMI, that spec that provides a low, uniform capability across service meshes, Meshery intentionally allows each mesh to expose some of its mesh specific value. One of those things being for Istio, in the Istio adapter, being that Meshery will run a series of checks, I was saying before, to help you verify that your service mesh config is doing best practices things. By the way, I guess I can't help myself in this regard to say that that particular subject, service mesh best practices and patterns, like that's actually the book that I'm just about to begin working on. And so hopefully through writing this book across the various meshes, we will, those that are using Meshery will hopefully benefit from the efforts to describe those best practices. So just to tie that back. Okay, so, yep, so you can use Meshery to deploy various configurations of the meshes, to deploy various sample apps. It might be that, you know, each of the meshes generally come with their own sample app, but you might actually, so Bookinfo is the canonical sample app for Istio. Bookinfo, many of you have maybe seen it. It's a very simple app. It looks like this when you're hitting the interface. We can talk more about how it works and what it does, but the point is that that's the Istio sample app. A nice thing about Meshery is that you can, it helps you intermix sample apps from one service mesh to the next. So if you wanted to run Linkerd and kind of see how maybe this sample app, the Istio one, performs on Linkerd, it helps facilitate that, which I think is also helpful in just understanding you know, the different behaviors, different capabilities, and different performance between the meshes. What was I gonna, I think I've been just running around talking about a bunch of different things without really having kind of a flow here. What I was gonna, you know, probably show is just that Meshery interface, you know, is a management plane. It interfaces with all the meshes and with Kubernetes. And so right now in this environment, I am running Bookinfo, that sample app, on my local Kubernetes instance. This is not going to be horrifically impressive, but if we were to sit here and watch the running pods, if we were to go, and so these running pods, those are the 4 services that are running for the Bookinfo app. There's a product page, you have details and ratings, the stars that you see, you can watch as Meshery unloads, you know, removes a workload off of the mesh. This one was running on Istio, which is why you see 2 of 2 containers ready inside each of these pods, because one of those containers is a sidecar proxy, an Envoy in this case. So there's more functionality in the tool, and hopefully a lot more to come. That's this has been the biggest kind of project that the community has been focused on. I think I could talk to you guys all day about service meshes and Meshery. And I want to make sure we did, I think there was another question, and it was, you know, the question is, you know, can I ask this in a GitHub issue or other channels? Oh, okay. Yeah, great. So the question is, how is the performance benchmark set up? Do you install some sort of like ping mesh? And since we have time, I'd love to answer that, because actually Kush specifically, he didn't know he was going to get called out this much when he joined today, but and actually Sako probably didn't realize this either. But the answer to that question is I think maybe there's multiple faucets to the answer to this question, but one of the answers is that Meshery is extensible in a couple of ways, in 3 ways today. And one of those ways is by choice of load generator. And so some of you may not be familiar with Fort.io as a load generator. It'll generate HTTP and gRPC load. And maybe more of us are familiar with WRK or WRK2. And so this is part of, I think, the answer about how it is that it sets up the performance test. There's a couple of components to that. One is that it'll deploy a mesh, it'll let you configure the mesh, it'll deploy apps on top, so that you can kind of get that aspect of the setup of the performance test ready. And then when you come over to this interface, you would take, like in my case, I think I removed this sample app, but we'll tell Meshery quickly to just maybe put the app back. And so while it puts the app back here, we can then grab the endpoint to this, app, generate load. You get your choice here. These two, these two, and then shortly a fourth. Some of you may or may not be familiar with. Well, you're most probably, many of you have heard of Envoy as a proxy. There's a sub project within the Envoy ecosystem called Nighthawk. Nighthawk is a load generator. It was built for purposes of testing the performance of Envoy. So Kush and others are going to be working on providing support for Nighthawk. And when they do, they're going to do it such that it won't be just Meshery sitting over here running like Fort.io or WRK2 basically inside of this server, inside of this container. Rather, the architecture that will be supported going forth, hopefully not just with Nighthawk, but with basically your choice of load generator, will be to do so in a distributed fashion, such that today we're generating load from a single place and pushing that over. Well, it might also be the case that you want load generated internally against some really popular workload here. And so maybe that workload needs to come as if it's coming from this other internal consumer, not just an external one. Or maybe you're like, well, hey, we've got lots of people in the US hitting us, and we've also got some popularity in China or what have you. And so we want to generate that load from multiple places. Point is, forthcoming over the next few months, hopefully, will be support for a distributed load generation. Yeah, and so on that, I'm gonna be quiet and say, thanks for listening to me about Meshery. Thanks for creating Goop as a place that I want to be. And it's a great community.
We love you, Lee. Thank you so much. And there is, I think, in the document, the 2 questions they put, I will just quickly tell, and if you can briefly, and then we will move to the next session. How big company may use Meshery?
Yeah, that's, and actually, yeah, it's funny. It's funny because there's an engineer at AT&T today who's been earnestly evaluating the use of, who's trying to help move their infrastructure forward. He's trying to understand what mesh he should deploy. He's a perfect user for Meshery. The way in which they would use it is to manage to understand their mesh performance ongoing. That's one. 2, they can use it to analyze the configuration of their service mesh, and Meshery will tell them, I was showing that example of Meshery sort of evaluating the config and telling them if they're doing it wrong or doing it right. As more time unfolds, those 2 feature areas, performance management and configuration management, they'll go deeper. They'll go, hopefully in the next 3 months as well, there will be a new visual topology so that people can see the various services on their mesh, where the traffic is routing, what the latency is for, like the example that I was giving earlier. If you configure your mesh to open up a request, look at who's signed in and redirect that traffic, like how much is that costing me? I can visually now see that that's going on, but is the latency there too great and going to push me over my SLO for that service? Anyway, I think there's a kind of a long-winded answer to how it is that large organizations might use Meshery. The other way in which specific to large organizations, they might use Meshery is that they're the ones that are more likely to find themselves using multiple types of service meshes. And so Meshery will provide a solution there.
And last question that, so what's the next thing of the mesh, and if it's causing any new issues when you bring the service mesh in your cluster? Because currently people are moving from virtual machine to Kubernetes cluster, and then if they bring meshes, what kind of side effects will have?
Yeah, one of those is like people get concerned about the performance overhead, and the thing that I think a lot of that's a potential issue. The thing that I think a lot of people forget or they overlook is that if you were doing path-based routing of your services today, or if you were getting a bunch of metrics about the requests going into your services or logs from them, or you were encrypting that traffic, or if you were doing any of the things that a mesh provides to you, you're paying for that and you're incurring overhead somewhere on whatever system you're using to do that. The mesh just actually consolidates it into under one layer, under one tool, and actually makes it a question that you can actually answer. You could actually say, well, this is the collective overhead of running MTLS. Whereas I think that those things were hard to answer individually before. The other thing that I consider that people will have a hard time with running a service mesh as they lay that down, well, is networking. Because that's a big old deep area that not all of us are, network engineers. And when you go to tweak the config of a mesh and you tell it to route traffic somewhere else, and all you're seeing is YAML, that can be it can be hard to figure out when you've tried to, when the traffic is not getting to where you thought you configured it to go. Like the tooling in this space is getting better, but I would expect that as people go to adopt the tech initially, that could be a challenge.
Okay, I think that should be it, Lee. Thank you so much. Appreciate your time and joining us. And we are moving to our next session. I think Elshad Agazadeh. He's going to talk about open source driven career. So it's 9:40 a.m. in SF-based time. So Elshad.
Hi, Shahryar. How are you?
Yeah. Thank you so much. Please share your screen and.
Sure, moment.
And I guess, yeah.
Can you see my screen?
Yeah, 1 second. I will stop.